Weapon is a missile. First, it flies long distances on its own using an engine. There are jet engines and rocket engines. Missile propulsion systems consist of jet engines that use liquid fuel and rockets that use solid fuel. A jet engine compresses air and sprays fuel to burn it, generating thrust. A rocket engine burns internal propellant to generate thrust. A missile also contains a guidance system that guides it to the target. The guidance system calculates the information obtained from various sensors to control the missile. Sensors include infrared detectors, or radar, and it contains a warhead that can destroy the target. The difference between a missile and a rocket is that the missile has a warhead. This warhead is activated by a fuse. The first missiles used in actual combat in modern warfare were the V-1 and V-2. The V-1 and V-2 were developed in Germany during World War II. The V-1 missile flew using a simplified jet engine called a pulse jet engine. Let's briefly look at the structure of the pulse jet engine. First, air and fuel enter the combustion chamber through the air intake. A spark plug is used to ignite the mixed gas. When the pressure in the combustion chamber rises due to the explosion, the valve closes. Then, the exhaust gas is expelled outward, generating thrust. When the gas is discharged, the pressure in the combustion chamber decreases. Then the valve opens again, letting in air and fuel, and an explosion occurs. This process repeats rapidly, and the resulting exhaust gas propels the missile forward. Pulse jet engine means it creates jets like a heartbeat. It measures distance using the rotation count of the front propeller. When it reaches the preset distance, the fuel supply stops and it falls. It maintains direction using a gyroscope located behind the propeller. Inside the gyroscope, there is a fast spinning top. A top that doesn't spin falls over quickly. If the top spins fast, it doesn't fall. What happens if you tilt the floor while Tiki top is spinning? Will the top also tilt at the same angle as the floor? No, it doesn't. Like this, a fast spinning top experiences inertia that keeps its rotation state. This inertia, called the gyroscopic effect, allows measurement of angle and angular velocity. At the rear, there is TNT explosive and a fuel tank. There is a device that controls the fuel, and the engine is located above. There are main wings and tail rudder wings. The V-1 missile can be considered the origin of modern cruise missiles. A cruise missile is a missile that flies like an airplane without changing altitude or speed much. The term cruise is the same as when we say an airplane is cruising. Cruise missiles use jet engines, so their speed is relatively slow. However, they can fly at low altitudes to avoid enemy radar. Over the sea, they can fly as low as about 5 meters, and flying this low makes them hard to detect by radar. Also, cruise missiles can change direction freely, like airplanes. Next is the V-2 missile. The V-2 missile was also developed in Germany during World War II. The V-2 missile flew using a rocket engine. Rocket engines are divided into liquid rocket engines and solid rocket engines. In a liquid rocket engine, the fuel and oxygen used as propellant are in liquid form. The propellant is pumped into the combustion chamber and ignited to generate thrust. The amount of propellant entering the combustion chamber can be adjusted to control speed. The V-2 missile is a liquid rocket that uses alcohol solution and liquid oxygen. Liquid rockets have many drawbacks. It is difficult to store fuel inside the missile for a long time. They are bigger and more complex than the simpler solid rockets, and also more expensive. Therefore, liquid rockets are often used in space exploration, while solid rockets are mainly used in missiles. If stored properly, solid rockets can be used for more than 10 years. Solid rocket engines use propellant in solid form. Ammonium perchlorate is used as an oxidizer to supply oxygen. The oxygen element contained in it provides the oxygen. Aluminum powder is usually used as fuel. Aluminum burns at high temperatures and is inexpensive, so it is widely used in solid rockets. Since ammonium perchlorate and aluminum are in powder form, they are mixed using a binder. A hollow space must be made in the center of the solid propellant. Therefore, the liquid state propellant is poured into a mold and hardened. The shape of the hollow space can be made in various ways. An igniter is used to ignite this space. The igniter contains gunpowder that ignites with an electric signal. Then the propellant catches fire and burns from the inside outward, generating thrust. The propellant is a kind of explosive, so once it ignites, it is difficult to control the thrust.
4000 का बिल है, मेरा गारंटी है कि आपका कम से कम 1500 रुपए कम करके आएगा। 15 किलोवाट लोड कैपेसिटी है, 15 किलोवाट, यानी एट ए टाइम।
The cross-section of the propellant is made in various shapes. Depending on the shape, the missile's thrust changes. This type of propellant burns in a specific way. As the surface area of the cross-section changes, the thrust also changes. The larger the surface area, the greater the thrust. The rocket's exterior often uses lightweight and strong aluminum alloys. When the propellant burns, it generates high-temperature radiation. To protect the exterior from this heat, the propellant is wrapped with insulation. The V-2 missile can be considered the origin of ballistic missiles. What is a ballistic missile? When a shell is fired, it flies in a parabolic trajectory. This path is called a ballistic trajectory. A ballistic missile is a missile that flies in this kind of parabolic path. At the start of launch, it ascends using the power of a rocket engine. Once all the fuel is depleted, it continues flying by inertia and then falls under the force of gravity. The V-2 missile flew using an inertial navigation system. This data is calculated by a computer in the guidance system, allowing it to determine how far the missile has flown. Since the inertial navigation system calculates internally within the missile, it is not affected by jamming signals. For this reason, modern missiles also use it as a basic navigation system. Today's inertial navigation systems are semiconductor-sized. The warhead contains TNT explosives. Ethanol and liquid oxygen are used as fuel. A turbopump is used to draw in the propellant and ignite it. The V-2 rose to the stratosphere at a height of 80 km above ground and flew over 200 kilometers. After winning World War II, the Allied forces used Germany's missile data to develop their own missiles. A missile is a weapon equipped with guidance functionality. Guidance refers to the function of directing the missile to the target. The main types of guidance are navigation guidance, command guidance, and homing guidance. First, let's look at navigation guidance. There are two methods that assist the inertial navigation system: satellite navigation guidance using GPS and terrain-referenced navigation. Satellite navigation guidance is a method of determining the current position using radio signals from satellites. Terrain-referenced navigation is a method of flying while scanning the surrounding terrain. There are two types: terrain contour matching, which flies by measuring the elevation of the terrain, and digital scene matching, area correlation, which flies by analyzing the shape of the terrain. The terrain contour matching method measures terrain elevation at regular intervals using a radar altimeter. The measured values are compared to pre-stored data in the missile as it flies. Digital scene matching area correlation takes images of the ground using a digital camera mounted under the missile and compares them with pre-stored images in the missile. Satellite navigation systems have the problem that GPS signals can be jammed by interference. Terrain matching methods are difficult to use in deserts or oceans and can also be affected by weather or changes in time of day. Therefore, missiles basically calculate their position using an inertial navigation system and use satellite navigation or terrain referenced navigation as auxiliary systems to correct errors. Next, let's look at command guidance. In command guidance, the missile does not decide how to fly on its own, but instead moves according to external commands. There are radars that track the missile and radars that track the target. A computer analyzes this information and sends commands to guide the missile. There is also a method of guiding the missile by aiming radar or an optical sight at the target. A similar method is beam riding guidance, which uses a laser beam to guide the missile. Command guidance has the advantage of simplifying the missile's internal structure, but has the drawback that it is difficult to use when the target is far away or out of line of sight. Lastly, there is homing guidance. Homing guidance means that the missile directly finds and pursues the target. Various types of seekers are used for homing guidance. First, there is an infrared seeker that tracks the heat of the target. Aircraft are easy to detect using infrared because of the heat generated from their engines. Early infrared seekers could only detect short wavelength infrared radiation from engine heat, so they were easily disrupted by flares released during pursuit. Later, sensors that could detect mid-wavelength infrared were developed, allowing detection of the aircraft's body heat as well. There is an image seeker that captures the appearance of the target directly using a camera. If the appearance of the target is pre-programmed into the missile, the image seeker can identify the shape and attack the target. It is mainly used to attack stationary buildings and is affected by weather, season, and time of day. There are infrared cameras that detect both heat and images. Infrared cameras have low resolution and have difficulty distinguishing heat rising from the ground. A method like this, where the missile follows signals emitted by the target, is called passive homing guidance. When the missile actively sends out signals to chase the target, it is called active homing guidance. Active homing guidance uses a radar seeker. Radar emits radio waves and detects targets by receiving the reflected waves. Radio waves have longer wavelengths than infrared and propagate better, so they can detect targets at a greater distance. Since the radar must fit inside the missile, its size is small. Therefore, the detection range is also short, around 10 kilometers. Active homing guidance is usually used when the missile is close to the target. There is semi-active homing guidance, which lies between passive and active homing guidance. In this method, the missile does not emit radio waves itself, but receives radio waves sent by a friendly source and uses them to track the target. Missiles usually use a combination of guidance methods. At the beginning, they fly using inertial and satellite navigation systems, receive command updates in the middle to correct the course, and then use seekers to track the target as they get closer. The guidance system is the computer inside the missile. It calculates data sent from various devices such as the seeker, inertial measurement unit, and command receiver, and uses it to control the missile.
एक बात समझो, डिमांड और सप्लाई का मतलब ये होता है कि अगर आप कोई चीज 100 रुपए में बना रहे हो और मार्केट में
The purpose of a missile is to destroy its target. Therefore, it must explode with strong force. The part responsible for the explosion of the missile is called the warhead. In the early 20th century, warheads mainly used TNT as the explosive. In the mid-20th century, high-performance explosives like RDX and HMX were developed. Warheads can be classified according to the type of explosion. First, let's look at blast fragmentation warheads. When the warhead explodes, the casing surrounding it shatters into small pieces, creating fragments. These fragments spread at speeds faster than bullets, making them very dangerous. Grooves are pre-etched onto the warhead's surface, so it breaks into predetermined shapes. Additional fragments are sometimes attached around the explosive. Next is the directional explosive warhead. This type focuses the explosive force in one direction. By placing multiple detonators around the outside of the warhead and only detonating one side, the blast force is concentrated in a specific direction. There is also a method that changes the shape of the warhead. First, the explosive is detonated to reshape the warhead. Then, detonating the explosive in this altered shape concentrates the blast force in one direction. Some warheads are pre-shaped, so that the explosive force is focused in one direction. This is called a shaped charge warhead. When the warhead explodes, the blast force converges toward the center. At the front, there is a metal liner, which vaporizes into fine gas under intense pressure when the warhead explodes. This metal gas is called a metallic jet. The metallic jet is much heavier than the explosion gases. When the heavy jet collides at extremely high speeds, about 6 km per second, its penetration power increases. It is used to pierce thick tank armor or bunkers. It can penetrate steel plates about 70 centimeters thick. When the warhead hits the target, the fuse is triggered by the impact. Explosives are loaded between two armor plates, and when impact occurs, the explosives detonate. This explosion pushes back against the shaped charge's explosive force. To penetrate reactive armor, a tandem warhead with two shaped charges was developed. The front warhead first triggers the reactive armor, and the main warhead in the rear penetrates the main armor. The warhead detonates via the fuse. Fuses can be classified as impact fuses, impact delay fuses, or proximity fuses. An impact fuse activates upon collision with the target. An impact delay fuse explodes about 0.5 seconds after hitting the target. Detonating inside the target, rather than outside, causes greater damage. Since missiles travel at very high speeds, they can penetrate a target in a very short time after impact. Detonation in this state describes the function of an impact delay fuse. To penetrate deeply buried bunkers, warheads made with steel cases weighing hundreds of kilograms are used. A proximity fuse explodes near the target. In the case of fighter jets, due to their high speed, direct hits are difficult. If a direct hit is unlikely, the missile explodes near the target to inflict damage. Missiles are also classified by launch point and target type. A surface-to-air missile is one launched from the ground toward an aerial target. An air-to-air missile is launched from the air toward another airborne target. These are typically launched during dogfights between fighter jets. In the next video, we will take a closer look at these types of missiles.
रमेश भाई, इस बार तो खूब सरसों हुई है।